So the other thing that we look at in regards to combining random variables has to do with the difference between two random variables. So we looked at this point at the sum of two random variables. Now we're going to look at the differences. So the formula for the difference in terms of the mean or expected value of two random variables is simply to just subtract what the means of the two random variables are. In terms of the variance, which we can use to find the standard deviation of combining two random variables, we have here that the difference simply is the square of the standard deviation of x plus the square of the standard deviation of y. So just notice here that even though we're talking about a difference here, we're still combining what those two variances would be. So an example of that would be something like this, and we're kind of revisiting here the example that we did previously with Pete's Jeep Tours and Aaron's Adventures. So we have X here that represents the number of passengers on Pete's trip, Y represents the number of passengers on Aaron's trip, C here represents the amount of money that Pete collects, and G here represents the amount of money that Aaron collects. And here's sort of a summary of that data there. So the question says, calculate the mean and standard deviation of the difference, and we're going to define the difference as being C minus G, in the amount of money that Pete and Aaron collect on a randomly chosen day, and interpret each value in context. So as far as finding what the difference in their means would be, all we would simply do here is to just subtract the amount of money that Pete expects to collect minus the amount of money that Aaron expects to collect. So we would say here on average that Pete collects $20 more per day than Aaron does. But just keep in mind that Pete's not going to collect $20 more every day. There's variability that's involved from day to day. So how much can we expect the amount of money, or the difference in the amount of money that they collect per day, to differ from the mean? Well, if we take the formula for standard deviation, or combining the random variables for standard deviation, we would take the standard deviation of how much money Pete collects, which is 163.5, and if we square that and we add that to the standard deviation of the amount of money that Aaron collects, which is 165.03, and we square that, if we find the sum of that, we get 53,967.15, and if we take the square root of that, we end up with a standard deviation of 232.31, which basically means the standard deviation of the difference in the amounts that they collect would be roughly $232.31. So we can expect on average that the difference in the amount of money that they collect will differ from the mean by about $232.31 per day. So with that, sort of a different kind of question here, but sort of a similar backdrop. And the question here says, a large auto dealership keeps track of sales and lease agreements made during each hour of the day. And we did a similar example to this in the previous lesson. Let X equal the number of cars that are sold, and Y the number of cars that are leased during the first hour of business on a randomly selected Friday. So here is the data for the amount of cars that are sold. Here's the data for the amount of cars that are leased. So the question here says, find and interpret the mean of the differences. So we're going to define the differences as being X minus Y in this case. So to find the differences, all we're simply going to do here is just subtract the two means, which in this case we would have as 1.1 minus 0.7. So the difference for that would be 0.4. So we would say on average this dealership sells 0.4 more cars than it leases during the first hour of business on Fridays. Number 2 says to compute the standard deviation, assuming that X and Y are independent, because remember, if we're talking standard deviation, then we must know that the variables are independent. So for this, the standard deviation for the amount of cars that they sell was 0.943, and the standard deviation for the cars that they leased is 0.64. So if I square those, add them together, take the square root at the end, standard deviation for this is 1.14. And then question number 3 says the dealership's manager receives a $500 bonus for each car sold and a $300 bonus for each car leased. Find the mean and standard deviation of the difference in the manager's bonus for cars sold and leased. So remember that by multiplying each of these values by 500 and 300 respectively, that's going to change both the mean and the standard deviation for each one of these. So in order to find the mean, if I take the amount of cars that they sell, or on average how many they sell, and multiply that by the $500 bonus, and then I take the amount of cars they expect to lease, which is 0.7, and I multiply that by 300, and if I take the difference between those two, this should be minus here, not a plus, we would get roughly about $340. And then to find what the standard deviation would be, I'm going to take the $500 times the standard deviation of the amount of cars that they sell. So this would basically be, I'm squaring both of these individually, but it's really these two times each other and then squaring. You could do it either way here. Same thing here with the amount of cars they leased. I'm going to do 300 times 0.64, and I'm going to square that product, and when I take the square root of that, I get roughly about $509.09. That's what the standard deviation would be in that particular case. So some different things that we're going to look at as far as kind of finishing up with combining random variables. We're going to take a look at some different things with the normal distribution and using the normal CDF in your calculator to answer some different questions about combining random variables. So the example here says Mr. Starn likes between 8.5 and 9 grams of sugar in his hot tea. Suppose the amount of sugar in a randomly selected packet follows a normal distribution with a mean of 2.17 gram and a standard deviation of 0.08 gram. If Mr. Starn selects 4 packets at random, what is the probability his tea will taste just right? So he's going to put in 4 packets, and what we're going to assume here is that each individual packet is independent of each other. So to find what the probability that he'll have between 8.5 and 9 grams of sugar, what I'm going to do first is to find what the mean is. I'm going to take, knowing that the mean of one packet is 2.17, so if I added the 4 packets together, I get a mean of roughly 8.68 grams. So keep in mind, that's on average what we would expect to happen if he put 4 packets of sugar in his hot tea, but he's not going to get 8.68 grams of sugar every time he opens 4 packets and puts those into his tea. There's variability that's involved here. So to find what the standard deviation would be, I'm going to take each of the 4 packets, the standard deviation for each of those would be 0.08, and if I square them and add them together, this would be the variance, 0.0256, and then to find what the standard deviation would be, I take the square root of that, which comes out to be roughly 0.16. So in order to answer this question here, what's the probability that he'll get between 8.5 and 9 grams of sugar in his tea? What I'm going to do next is I'm going to use the normal distribution. So here is the normal curve. Notice we have the mean in the middle, 8.68, and then here's the standard deviation, 0.16, going in both directions here. So what I want to do first is I want to find what's the z-score for 8.5 and what's the z-score for 9. So this right here represents how you would find the z-score for 8.5. This right here represents how you would find the z-score for 9 grams. And then here are the z-scores for each one of those. And if I do the normal CDF in the calculator from negative 1.13 to 2.0, so if I kind of come back to my calculator here, let me sort of discard this. I'm going to pull my calculator up. So with this right here, if I did the normal CDF from negative 1.13 all the way up to positive 2, and if I paste that in there, there's the probability for that right there. So this would be roughly about 0.8480. So that's the probability that he'll get between 8.5 and 9 grams of sugar in his tea there. So that's just a normal distribution problem that's involved with something like that. What we're going to finish up with here is a normal CDF problem involving the normal curve and combining random variables, but I'm going to show this to you in sort of a state plan to conclude type of format. So the last question here says the diameter C of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inches. So key things here are we have a normal distribution, here's the mean, here's the standard deviation. The diameter L of a randomly selected large lid at this restaurant also follows a normal distribution with a mean of 3.98 inches and a standard deviation of 0.02 inches. For a lid to fit on a cup, the value of L has to be bigger than C, meaning the lid has to be bigger than the cup, but it can't be bigger than 0.06 inches. So we don't want the lid to be too big that it will not fit on the cup. So the question says, what is the probability that a randomly selected large lid will fit on a randomly chosen large drink cup? So in terms of state plan do conclude here, first thing I have is this. What is the probability that a randomly selected large lid will fit on a randomly chosen large drink cup? So remember, the state part, you're just restating what the question is asking you to do. The plan here is we're going to define the random variable D as the difference between the sizes of the diameters in the lid and the cup, and we're going to represent that by finding the probability that the difference in their sizes is somewhere from 0 up to 0.06 inches there. So the do part of this is first I have to find what is the mean of their differences. So that's simply just taking the mean of the lid minus the mean of the cup, which comes out to be roughly 0.02. And then to find what the standard deviation of the differences would be, I take the standard deviation of the lid plus the squared plus the standard deviation of the cup squared, and I get 0.0005. And if I take the standard square root of that, the standard deviation comes out to be roughly 0.0224. So from here now, I can start to look at the normal CDF and Z-scores. So if I take first the Z-score for what 0 inches would be, and that's this right here, I get roughly negative 0.89. And then if I find the Z-score for 0.06, which is what this is here, I get a Z-score of roughly 1.79. And if I go to the normal CDF in your calculator and I do the normal CDF from negative 0.89 to 1.79, I would get a normal CDF there. I would get a probability of roughly between of 0.7766. So my conclusion for this is going to be that I have a 78% chance that a randomly selected large lid will fit on a randomly chosen large drink cup at this restaurant, which basically means that 22% of the time the lid is not going to fit properly on the cup. So that's just some different things that we do with the combining of random variables that are involved with the normal CDF and the normal distribution. Just remember, just a quick thing here, just remember that in order to do the normal CDF in your calculator, one of the things that you have to compute first here are the Z-scores for whatever the X values are that you're trying to find the probability with.